In this example, this is 6.2.6. We're going to do DTFT of this aperiodic sequence. Now this aperiodic sequence stretches over all time, even though this is very small values here after maybe 15, because 0.8 to the power of n will never go to 0, so it has infinite support from n equals to 0 to positive infinity. And in this particular example, then you realize that we cannot really write or compute this by brute force as in our MATLAB example. So what should we do? We realize that this is a geometric progression and we can actually reduce it into this equation. The other way which I prefer to do this is that I will use the Z transform. I know that the Z transform of this sequence is Z over Z minus 0.8 with region of conversion greater than 0.8. Alternatively, I can convert this into by multiplying 1 over Z on both sides. I can convert positive powers of Z into negative powers of Z. So what Z times 1 over Z is 1. This is 1, and minus 0.8 times Z minus 1. Remember that to convert Z transform into Fourier transform, we substitute Z equals to Ej omega, where we are actually examining the Z transform on the unit circle. So Ej omega is the unit circle because now omega goes from 0 to 2 pi. This is 1 Ej omega. So we are doing 1 Ej from 0 to 1 Ej to 2 pi, which is actually exactly this ring over here, the unit circle. This is real part of Z, this is imaginary part of Z, and this ring is radius 1, and then this is theta. The theta will go from 0 to 2 pi. Now, so when we substitute Z as 1 Ej omega into this expression here, isn't this simply 1 over 1 minus 0.8? Z is Ej omega, the minus 1 remains, and you will see that it is exactly this equation that we have written over here. 1 over 1 minus, then here is gamma is 0.8, E minus j omega. And of course you can then go ahead and express this in the rectangular form, and then substituting different omega, you plot the magnitude and you plot the phase. So again, you can plot from 0 to 2 pi, minus pi to pi, or in fact any range of values that you want. So this is what you will get, and this is the closed form equation representing this, which is a complex value into magnitude as well as phase. So go ahead and write your MATLAB code to plot this expression, and you realize that this is the same. Right, thank you.